It's Liz with the Plymouth Public Library with Homeschool at the Library. I am excited to be here with you today because we're talking about space. Super exciting topic. Now, this week I have a special theme for you because I had the opportunity to go visit an astronomer by the name of Dr. Todd Hillwig at Valparaiso University. He's a professor there, and he showed us the telescope and his office and a lab, and I am excited to show that to you right now. Hello everybody, it's Miss Liz again with Homeschool at the Library from Plymouth Public Library. Today I am so excited because we are studying space, and I have made an appointment for us to come to Valparaiso University's Observatory, you can see in the background, and their Office of Physics and Astronomy here at Valparaiso University. We are going to meet Dr. Todd Hillwig, and he is part of the department here, and we're going to get ready to go into the observatory, see a little bit of that, and learn about what astronomers do and about telescopes and space. So get ready to come with me. Hi guys, thanks for coming back, and I am here at Valparaiso University in the Physics and Astronomy department with Dr. Todd Hillwig, and we are going to set up a small little interview so you can get to know him and his department. Hello, Dr. Hillwig.
Oh.
How are you today?
I'm doing well. Thank
Good.
you.
I'm glad that you offered to meet with me and the students. And a couple questions that I know we have for you is, one is, what is your position here at Valparaiso University?
I'm a professor of physics and astronomy, so I teach both physics and astronomy. And a lot of people don't necessarily understand that astronomy is a sub-branch of physics. So what we do, there's a lot of physics in it, a lot of mathematics. It is a science, so like some areas, a lot of people have heard of nanophysics, for example. That's a sub-branch of physics in many ways, just the same way that astronomy is a sub-branch of physics.
Okay, good. Thank you. And what did you have to do to be in the position you're at right now? What type of schooling and things, or to prepare people who might be interested in doing what you do?
Yeah, so I went to college and got a degree, a bachelor's degree in college in physics and mathematics. And then I got a master's degree as well. That's not required, but what is required is a PhD, a doctorate in this field. And so I went to graduate school. It took me 6 years to get my PhD. And then even beyond that, most positions like mine, most faculty positions these days at a university also require you to do some independent research after that before you get the job. So I was in what's called a postdoctoral research position for 2 years. That meant I worked for someone else and I did research full-time. I did partially their research, partially my own research, and the idea is that helps you to get into the idea of research and being able to do research in your field in a way that's different than when you're in graduate school. So it's really like an internship after your doctorate, or for medical students, they have residencies after they become a medical doctor.
Right.
And it's very, very similar to that.
Okay. And so what is one thing when you we're starting to learn about the stars and things like that, like what excited you most about space?
I think it was the idea that we can understand most of what's going on out there. There are plenty of things we still don't know, right? I mean, you look out and you see a star, and it's this little point of light, but I can take our telescopes and I can look at that star, and I can gather the light coming from that star in different ways, and part of what I do now as a researcher is I look at stars, and there are some stars that just by collecting light from the star, I can figure out there are actually two stars there, and they're orbiting around one another in a few hours, and one of them is so hot it's heating up the surface of the other star, and sometimes they exchange mass. So one of them actually dumps material onto the other star, and I can figure out their temperatures, I can figure out their sizes, I can figure out the mass, how much material is there, all from just looking at a little point of light in the sky. And that fascinated me, that by understanding the basic science, we can take that kind of information and figure out so many different things about it.
Now, can you explain what a white dwarf star is?
Sure. So a white dwarf used to be the core of a star like the sun. So the sun's core is undergoing fusion. It's converting hydrogen into helium, and that's where the sun gets its energy. And so that inner part of the sun is really hot and really dense. And eventually, it's going to run out of hydrogen. It's going to convert all of it into helium. And when that happens, the core actually starts to shrink in on itself and gets hotter. And so this process goes on over time, and eventually the core just can't do anything else. Mm-hmm. So the outer layers of the star get blown off out into space, and you're left with this core. And the core is what eventually becomes a white dwarf. In fact, the way I study them is I study them right after that happens. So I study planetary nebulae, and that's where the outer layers of the star are actually blown out into space, and that core is so hot it makes them glow. So we see these really beautiful, colorful, intricate shapes and patterns that used to be the outer layers of the star, and now the core is left in there. And what we think is that some of those really cool patterns that we see some that look like butterflies or hourglass shapes and rings and all sorts of crazy shapes. We think that that might be because there are actually two stars there.
Okay.
And so that's what I'm studying.
Now, when you study stars, what type of equipment, telescopes are one, but what other type of equipment do you use?
Computers.
Okay.
And one thing about astronomy is that astronomers tend to use computers more than any other field other than computer science. So
we probably didn't know that, but I guess that makes sense.
Yeah, it's gone are the days when we look through a telescope with our eye and sketch things. Okay. Now it's all about putting a digital camera on the back of the telescope, and you record that as an image on your computer, and then you go on the computer and you measure the light coming from an individual star on that image.
Yeah.
Or you split the light up into a spectrum, into the different colors, and you record the different colors on a camera, and you measure how much light is coming from each different color, and by doing that we can tell a lot of things about the star as well. Now,
what is, I know they name the stars. How are stars named?
Right, so stars are generally named in, so there are about as many different ways of naming stars as you can think of. A lot of stars have really fascinating names, like HD 173428.
Yeah, that's very fascinating.
Right, isn't that fascinating? So it turns out that most of the names that we know for stars, that are names sort of like, Betelgeuse, those are ancient names from history. The current thinking is we don't really name stars that way officially. The only things we officially name are things inside of our own solar system. And it's sort of this idea that stuff doesn't belong to us, right? All the stuff that's out there, it's not associated with us. We're just observing it. The things in our own solar system, okay, those affect us. They're part of our home, right? And so we feel okay naming those. But formally, there's a group called the International Astronomical Union, and they're the ones who formally designate names for objects outside of the Earth.
Okay.
And so they have decided that we're not going to give popular type names to things outside of our solar system. So we're mostly stuck with catalog numbers.
Yeah. Okay. Now, I'm going to have the kids look up something, and I would like them to look up your favorite star. So
wow, my favorite star.
Like one of your favorite stars. And they can look that up and do a little research. So here's some homework.
I think one of my favorite stars is probably Betelgeuse, the one that I just mentioned, for a lot of different reasons. It's not a star that I study in particular, but I just find it completely fascinating for a lot of different reasons. The size of the star, where it's at in the sky and how close it is to us. It's not particularly close, but relative to a lot of other kinds of stars like it, it's fairly close. One thing you should do is go out and try to find the size of Betelgeuse compared to our solar system. There are images out there that actually show here's where our sun would be, and here's where all the planets would be, and this is how big Betelgeuse is compared to those.
Okay.
And
we have books we have some nice books at the library also, even in the adult section on astronomy, and you can find some images. I actually was just looking at an image of Betelgeuse, and just on the way here.
Great.
So, if you could give them pointers to do right now, to study and to prepare themselves for those that are interested in astronomy, and what to prepare themselves for maybe a future in astronomy at this point in a young life.
So I think there are a couple of things that I would say. One is maybe something that might disappoint a lot of them, and that is math. Math is really important. You don't have to love math, but you do have to learn math. Math has never been something I've particularly loved, but I have to know it to do what I do. Which is good to know. Thank you for sharing that. Yeah, and again, it's not something they have to look at and go, oh, I really love doing this. But you have to have enough dedication to learn it and be willing to learn it and know it. Yeah. And that really comes over time. I know a lot of students, in fact, we homeschool our boys, and math is something that they struggle with. They don't really enjoy it. And one thing that I'm trying to get across to them is you need to learn it, and it's going to take time, and you shouldn't expect to just look at it and understand it. And I think that's one of the difficulties as we're growing up. We see something and it looks kind of hard. And maybe it's not that it looks hard, it's maybe that we don't really understand it immediately, and so we tend to go, oh, I don't like that, and I'm not good at it, which is not true. Yeah, see, did you hear that? It's not true. Continue studying math and doing very good. Thank you. That's very good pointers and everything. The second thing I would say is that a lot of people think about science as all pure logic, and there are just rules, and you just have to follow the rules. And there are laws of physics, and we have to stay within those in our understanding of the universe, right? Or we don't understand it. There's simply guidelines that we have to follow. But when you're actually doing research, there's an incredible amount of creativity to it, because you have to see different parts of things and be able to see how they fit together and how those things work together. A very large number of people with PhDs in physics and astronomy play a musical instrument or paint or have some significant kind of artistic part of themselves that they really enjoy. And so I would encourage you to not think about science as completely separated from art and from creativity, because it's not. Well, and I think some of the most beautiful images I've seen on pictures is of space, of stars, of nebulas, of different astronomical, just things out in the universe. It's so fascinating and gorgeous. It's just gorgeous. Yeah. And in many ways that makes my job easier, because as scientists, we want non-scientists, we want everyone else to understand what we do and why we're doing it. And when we can show them these really beautiful pictures, especially because I study planetary nebulae, and some of those pictures are gorgeous, they're just beautiful. And so it's easier to go, look at this beautiful picture. This is what I study. And here's why I'm studying it, and here's how I'm studying it. Yeah, so not just like science is art. It's beautiful. Well, I want to thank you for this time here. In your office here at VU, and now it would be really nice for you to show us the equipment you use on campus here. If we can go ahead and head over there. Yep. All right, we'll see you in a bit. So this is our campus observatory. This is what we refer to as our warm room, because the telescope itself, we can't actually heat that area, because if you've ever looked across a blacktop road during the day, and you see the heat rising off of it, that's exactly what would happen around the telescope, which is right through this side of the room. And if you heat the interior of the building and then you open the dome so the telescope can look out, all that heat would go right out and you would see all that waviness. But we're also, we don't want to sit in the cold and do our work, so we have this small room where we control everything using computers. So we have several computers here, and we can look up objects that we want to view with our telescope, and with a click of a button we can send the telescope straight to that object. And this is really a student observatory, so we have students here who know how to run this place better than I do as a professor, and it's because they're here much more often actually using the telescope. If anything breaks, it's my job to fix it, and we have another staff member who does that as well. And so we know how to fix things, but as far as the day-to-day operation of actually pointing the telescope and using the camera that's on the telescope, our students actually understand that better. And that's on purpose. We do that intentionally because the main purpose of this facility is to train our students in how to use a telescope, how to be an astronomer, and how to study the universe. So that's really the goal of it. Our telescope is pretty decent sized. It's 16-inch telescope. That means there's a mirror in it that's 16 inches across. Right? And for a typical university, that's a pretty decent sized telescope. And even though we're in the middle of Valparaiso and we're near Lake Michigan and we're not at a very high altitude, all those things work against us in using a telescope because the city has a lot of bright lights, and being near the lake means there's a lot of moisture in the air, and we just can't see as much from here as, say, we can at the U.S. National Observatory out in Arizona, where it's very dry because they're in the desert, they're on a high mountain, so they're above most of the Earth's atmosphere. So areas like that work better for looking through a telescope, but it's really cool to point our telescope to something like Saturn, and you look through it and you see the rings of Saturn with your own eyes. And we can do that here. In fact, there is research that we do here as well. And again, that's mostly involving our students so that they can get that experience. But the basic idea of this facility, again, is just to be able to look at some of the basics, look at stars and some bright galaxies as well, and some nebulae, all sorts of different things. And in addition to students, we also want to reach out to the public. So we have public open house nights. Typically, not during the pandemic, unfortunately, but on typical semesters, we have this observatory open 7 Friday evenings every semester. And we let the public come in, and while we usually choose objects that are nice to look at through the telescope, a lot of times we'll have people come in who are really they love what we're doing. They love to look through the telescope, and sometimes they'll give us objects and they'll say, can we look at this? And if it's possible to see through our telescope, then we'll point it there. So if you decide to come here and you're interested and there's a star or something you really want to see, let us know, and we'll see if we can look at that. So this is our campus telescope, and this is what's referred to as a reflecting telescope. So most of what's in here are mirrors. So there's the primary mirror, the main mirror that we use is down here at the bottom. And it's a mirror that is about 16 inches across. So the light comes in through the top, bounces off of this mirror, and goes back to the top again, where there's a second mirror facing downwards. So it comes in, bounces off that second mirror, and goes back down through a hole in this mirror. There's a hole in the center. And then it goes down to at the bottom here where we can put whatever we want. Right now there's a camera on here, and so we can take pictures through that. And there's also an eyepiece, so there is a lens in there, and we can redirect the light through the lens so that we can actually look through it. So it's set up right now so that we can do either. We can take pictures with it using our digital camera, and it's a camera that's a lot like the cameras in a typical cell phone. That kind of digital camera, it's significantly better than most cameras in cell phones as far as sensitivity, because we're trying to look at things that really are fairly faint. Your typical cell phone camera expects a lot of light to come in, so it's not real sensitive. So our camera on here does a better job of collecting light, and that way we can look at things that are really faint. And the idea of a telescope like this, the reason it's big, and the bigger telescope the better, is not for magnification. It's not to make things look bigger in particular. It's to collect more light. So it's bigger, so we talk about it like a light bucket. So the bigger the bucket, the more light you can collect. And it's like if you were to go into your bedroom and you have the lights on and you're reading a book, right? You can read the words on the book, and if there's a picture, you can see the colors and see what the picture is. But if you turn the lights off, and maybe there's a light out in the hallway, but there's not much light, it's hard to see the colors on the picture, and you may not be able to read the words. That's because there's not as much light going into your eye, because there's simply not enough light bouncing off of the page. So when we want to see things in the universe, we really want to collect as much light as possible. And that's why the largest telescopes in the world right now are 10 meters across. That means they have a set of mirrors that the mirrors are literally 10 meters across. That's larger than this building. So the telescope itself is significantly larger than this building. And those telescopes can see the most distant things in the universe, not because they can zoom in on them, but because they can collect so much light that those things that are really far away, even though we're getting just a little bit of light, we can collect that and actually see them. So this telescope and this mirror simply acts like a light bucket. It just collects light and allows us to see it.
All right, well, thank you, Dr. Hillwig. I am so thankful that you let us come and meet you, and I hope that many of you are excited about astronomy, and you look up Dr. Hillwig's favorite star. Don't forget to look that up, and message me or email me back about what you find out, or put it in your journals that I gave to you. And if you just have any more thing you want to say to the students.
Thank you for the opportunity to talk to you. We really enjoy talking about what we do, and I love talking about what I do and being able to introduce it to people. And so if you have questions, I can try to respond to questions. Yeah, please, once we open back up, come to the observatory for our open houses and let us know that you're interested, and we'd love to see you here.
Okay. Thank you. Thank you. It was a great honor to get to visit with Dr. Hillwig at Valparaiso University. I was just excited about that, and I hope that you were too, and that we get to visit the observatory sometime. That'd be great to even plan a trip together when it opens back up. Anyway, today we're talking about space, and you have packets here at the library if you didn't get it. And if you haven't been getting them, I've been trying to include a space passport for each of us, for each of you to be able to write. We're going to study each planet. So you would write in the first page, like the first planet closest to the sun is Mercury. So you would write Mercury because that's where you're going to visit first. And you would draw pictures or put some ideas and thoughts in here. And in your packet also, I have a couple of coloring pages with the planets with a little bit of information. Just the inner planets. That would be the first 4. And then a Land Rover for Mars coloring page about Perseverance. Also in your packet, you'll see is our craft, a little bit of some fun craft stuff that you can work on at home, and we'll do that together in a little bit. So stop in the library, and while you're at it, check out some books. There's books on many books, small easy books. There's tween J books, different levels of reading that you can look up with information. There's in the adult section of the library. There's also some very larger and higher vocabulary books about space and the stars and the planets and things like that. So if we could start, and you go ahead and get your passport out, and I want you to look up information about Mercury. So you can check books out, or you can get online. I'm going to give you a few little tidbits about Mercury. Right now, it is the smallest planet in our solar system, and it is the one closest to the sun. The next thing is, it's like about the size of it's close to the size of our moon, apparently. And even though it is the closest to the sun, it is not the hottest planet. We will learn about the hottest planet in a bit. It spins very slowly in a rotation just spins around very slowly, but it goes around the sun very quickly. I believe it takes 88 Earth days for Mercury to make one rotation around the Earth. I mean, around the sun. I'm sorry, around the sun. Anyway, it does, Mercury has no atmosphere, and it also has been visited by 2 spacecrafts, not specific, like flybys and images taken of Mercury. It is a light gray in color. I think they add color onto some books so it brings out some characteristics of the planet. But it's basically comes across as light gray on our photographs of it. It has been visited by Mariner 10 and also Messenger that has gone by. And oh, there's a star-shaped crater on Mercury. So be sure to put all that information in there and find some more that you can add. And then you'll go to the next page and you're going to write that you are going to learn about Venus. So write some information about Venus. A little bit of information is it is the hottest planet in our solar system. And it is bright in the sky. You can see it without a telescope. And that's because I think the atmosphere, it said, that it reflects, you can see it because of its brightness. And it is a toxic environment, it says, and a lot of sulfuric acid. It's very active. It's also a terrestrial rocky planet. It takes, there's 5,000, this was interesting to me, 5,834 hours in a day, like Earth Day. We have 24 hours in an Earth Day, and they have 5,832 hours in a day. It turns, rotates, it circles very, very slowly. And it has 0 moons. Venus has no moons. And it has been visited by several spacecrafts that fly by. And I'm trying to think of other things. It is 67 million miles from the sun. But you find more information, look it up, look online, get books and stuff. The next planet you would put is Earth. And everyone has been to Earth. So, because you live on Earth. And it is the only planet in our solar system to sustain life. And you should research why that is. Some of the reasons is because it's 70% water on our planet. It has an atmosphere, it's oxygen, it's perfect distance from the sun. Everything about the Earth, where it's located, how it turns, everything about it is able to sustain life. It's perfect. So it's very neat. So write some information that you find about the Earth. And then the 4th planet from the sun is Mars. It is the red planet. I think we talked a little bit about that last week. Mars is red, but not because it's hot. It's actually cold. And the super cool thing about Mars is that there is a Land Rover. Land Rovers have landed on Mars. Here's a book at the library called Curiosity, the story of a Mars rover. Now, hopefully there'll be another book coming out called Perseverance. Perseverance is a Land Rover that is going to be landing. It is already launched and on its way. It is almost to Mars. It is going to land, and you can watch it live on February 18th, 2021. So I'm going to send you a little trailer from NASA that you can watch right now about the Perseverance Land Rover. now we can go ahead and get the craft stuff out of your kit that you got. If you did not come to the library and get this, it's okay. Just use what you have at home because it's very simple. I just thought this would be fun to do. So, and I think we'll do half this week and then half next week. It's very simple though. You just take coffee filters, circular coffee filters. If you don't have coffee filters and you want to use paper towel or something similar to that, but coffee filters work really well because the water, it'll spread out. So what we do, and you'll need some glue if you want. I thought glue would be fun. So, and a spray bottle with some water in it, and markers and scissors. So now take your coffee filters, and what we're gonna do is just make them like the planets. Of course, they're not gonna be to scale. We watched a video last week. Can't make those to scale, otherwise you wouldn't be able to see them. So I cut some out just practicing, but you want to take and we're going to do them by size. So Mercury is the smallest planet, so you want to cut Mercury out and make it super tiny. So I'm going to just cut, you can cut however you want, okay? So, and they don't have to be perfectly round because the planets are not perfectly round. Okay, they never said anywhere that all the planets are perfectly all the same circular, you know. There might be some mountains in there, some craters in there, you know, so that's fine, okay? Just make it how you like it. And so we have Mercury, and then we're gonna have Venus. Earth is the largest planet in the inner planets, but I'm going to save this whole size one for Jupiter because it is the largest planet in all of our solar system. So with Earth, then we just cut and make it a little bigger. I don't know why I skipped to Earth. Probably because I wanted to, because I love Earth, because we live on it. So there, so we just have Earth. You can save these and color these also. And we're gonna do Venus. So just make them different sizes, okay? However you want. No one's going to complain if they're not quite drawn the same. And then Mars, which is half the size of Earth, they say. So, I mean, you technically could fold it over and make it half the size of Earth, but if you wanted to be very technical, you can get your protractor out and work on that. I am not doing that. I'm just going to cut them. And this is just, okay. So we have some planets here. Okay, and then move that aside. Okay, and save the other coffee filters because you'll make the other 4 planets. Sorry. And then all you have to do is color it in with markers. And myself, I think since Mercury is gray, I want to do gray. But you don't have to do gray, and you can just color it around. Just draw lines. You can add different colors. So, and just, I would use a tray or a paper plate. If you have like a styrofoam paper plate, you can do it on there because you won't, it'll catch the water when you spray it. You're gonna spray this with water when you're done. So there's some gray, and you know what, you might wanna, you're like, oh, I want a crater. I didn't get a black marker, I forgot, so. But you can get a black marker. Maybe you wanna do that star-shaped crater thing at the bottom of Mercury, kind of. It's got some like lines in it or whatever. Okay, and then you're like, oh, there's Mercury. And I would get paper and write, make a little note. It says Mercury and put some information on it also, if you want to label your planets. So let's do Venus next, and maybe Venus will do like brown, bluish, yellow. I'm gonna say blue and green for Earth because that looks like Earth, you know. You can draw the planets here. So let me get this. Well, you can do any color you like, you know, so you can color, Venus is bright, kind of, because of the atmosphere, and it's the hottest planet because, and you can do it darker, however you want, and maybe a little bit of brown because, you know, just do some, you can do lines, color sections, whatever. And then Earth is green and blue because of the land. So you can, of course, my green is dried out. So I'm gonna spray it already with water. So it can freshen it up a little bit. So there's some, or you're gonna just draw Earth. You can actually draw Earth however you want, like do South America, North America, Asia, you know, however you wanna do that. I'm not gonna, you might wanna check your markers before you start. I did not think of that. You can draw some islands. That's okay, because you're gonna spray it with water. And then you can draw the blue for the oceans. Can, you know. And then Mars, I think I'm gonna do red because it's the red planet, maybe some brown. But you do whatever color you want, okay? Stuff like this. So I'm just drawing lines. Super fun. And maybe a little bit of, maybe if you add some like yellow to it, it can turn it orange. You know, when you add the water, if the red and orange will mix. You know, and there's other, you know, you can use other colors. Here's pink, which looks red on my coffee filter. And then if you wanted, you could add glue to it, which I'll do later, and you could put a little glitter or whatever and make it look bumpy. So when the glue, and let the glue dry. But so if you spray this on the coffee filter, the colors just bleed through. You can see it just forms. So you don't have to make it super wet. You can just, here, like, you know, and then you can add, and then it'll dry. Well, you hang them up to dry. Because the coffee filter just filters the colors right out. See? And then if you use, like, you know, yellow and red will make orange. So it might leave some orangey color. And then if you wanted to, either you can wait for the coffee filters to dry, but I'm going to do it right now so that way you see it. Then you would just, you can add glue to it. And so you have it like, you can build mountains, you know, and put some glue. My glue might be a little bit dry on the end. You know, and add a little glue so it's kind of bumpy. And then you can stir that around a little bit so it's colorful. It'll dry clear though. And then you can add more, you know, and you can just add designs to it or whatever. It'll dry and be, then once it dries, you take contact paper if you like, and you laminate it basically. You can add glitter too if you like glitter, and Mom doesn't care. And then there. So you're gonna hold, and then you're gonna laminate it, after it dries. Let it hang or lay it somewhere. And the markers will stain also, by the way. It's gonna stain, so you have to wash your hands when you're done. And don't touch white stuff in your mom's house. So what you wanna do is let it dry, and then you can laminate it or just hang it up on a window and have like a sun catcher of some sort. So we'll do those inner planets, write down information about them. You can label them, and then we'll finish the rest of that project next week. All right, that concludes today's segment. I would like for you, if you have a chance, to write Dr. Hillwig a thank you note, and you can either drop it off at the library or email it to me and I'll print it out and send it with our thank you packet for helping out, showing us the observatory and giving us some information. Also, if you still wanted to connect with another student in this group as a pen pal, don't forget to email me your name and age and your hobbies, things you like, so we can connect you with someone so you can have your pen pal for the rest of the remainder of 2021. Anyway, hope to see you soon. Come into the library, and I am excited to continue learning about space. We'll see you soon. Bye.